First of all, let's put me into context. So I'm here today as an independent consultant. I've been working in the technology, media and telecoms sector for many, many years. And I recently left the operator fields. I was predominantly in operators, whether they be startups, whether they be incumbents, people that operate copper networks, fibre networks, and the transformation of them over time. So I've seen quite a lot of transformation during that time. I've worked a lot on transformational projects to help organisations take advantage of new technologies and to move forward with a more optimised network operation to help them move forward. Again, lots of nice words. So I've got a bit of a journey to take you on today, because this presentation is more about AI than anything else, and I'm hoping that there's people in the room that are going to say, oh, that sounds a little bit more interesting than working out the best way for service operators to take things forward and improve their operation. The way they're going to do this, and the way I'm going to tie this into AI, to telco, and then to the particular product that Canopus offer, I will explain as the session unfolds. We've got two public retainers at the moment. There's a couple of private ones as well that I'm not at liberty to talk about, but Canopus is why I'm here today. Telenova are a telco-based advisory service, transformation service, and then operator support service as well. So, but it's Canopus that I'm here to talk about today. So, hopefully I'm going to take you on a journey. I'm going to go at quite a pace, so I apologise. You've just had your lunch, you don't want pace, you just want to sit comfortably in your chair and kick back. But I'm going to go at a pace because there's quite a journey to really bring us up to speed. And I understand from Tony that you've not had AI as a topic in any of the SET events in the past. So I'll need to make sure that we're all kind of at a similar level first before I start throwing you into large language models and how they work. First of all, I know we've got some telcos in the room. I know we've got some vendors. Have we got any AI experts in the room? Anybody that thinks they're really proficient on AI?
After you.
Well, we've got a wavering hand up there, and is there any students in the room? That's good, because they know how to use it best, don't they? They're the ones that manipulate the technology. They've found every angle to write their content. Right, I'm going to move on now with a little bit of a history slide, just to help put a little bit of historical context. So the Homo sapiens, us, we've been on the planet for about 100,000 years. As a creature, and the planet, let's look at this top left-hand corner. The planet is 4.5 billion years old. That's the grey band at the bottom. And laid on top of it, you can see different coexistences throughout time. And Homo sapiens is the second from top one up there, indicating 100,000 years. Now, clearly, that is a logarithmic scale. Okay. There's no, we don't compare to the existence of the planet. We've only been around for 100,000 years, but as a civilization, cleverly communicating and evolving and getting to where we are today in this lecture hall, we've only really been at it as a civilization for about 12,000 years, right? That isn't a blink. It's not a hair's breadth of existence of what's happened on this planet over the 4.5 billion years of it. And in the last, so this bottom chart is indicating when we became hunter-gatherers about 12,000 years ago, and the evolution and some of the agricultural revolutions, etc., and then the industrial revolutions that we've had in the last 200 years, where we had the introduction of steam and the textile machining, looms, etc. Then we had, in about the 1800s and in the 1900s, we had, I should have put my glasses on, that would help. Why can't I see that now? Then we created glasses. In the 1900s, what do we have? We had a bit of electricity, yeah? And we started to see some mechanical engineering coming about from the back of the electricity. Telegraph, telecoms, telephones, all of that came about in the 1900s. And then about the 1950s, we started to see digitalization. And the technologies that were born from a digital sector. We were looking at computing, automation, the emergence of globalization, and the phrase AI was coined in the 1950s. You wouldn't have thought it, given it's everything everybody ever talks about these days, but back then, that's when AI was first born. We haven't really seen anything of it until in the last 2 to 3 years, and I'm sure You've all got some AI on your body, I'm sure. You've all got phones. They use AI in lots of different of the applications that you're in on those phones. You've got it in your home, we've got it in this building. We're still going to see a lot more of it over the next few months. As I'm talking months, I'm going to talk years because it's happening at such a pace. What I liked about this chart, I did punch it off the web. There was supposed to be a source on there. Don't know if it disappears. Oh, there is a source on there. Let's go back. There is a source on there, it's not visible on this particular background. But I love about this slide is that after these 4 most recent revolutions that we've had, the chart carries on upwards on an exponential shift into the world of AI and the likes, or it drops off. That's not my manipulation, that was just a graphic that we got there. It drops off and it's the end of civilization as we know it. Let's hope. Is there anybody in the room that thinks that we're going to drop off? Yeah, there you go. There's not, and you know what? Nobody in this room can prove you wrong. We don't know. We are creating something, a new technology, which we are going to give itself the empowerment to evolve. I'm not going to get into the debate of whether or not it becomes sentient or cognizant of their surroundings, etc. But it will grow and develop itself. It will machine learn and evolve and grow. And we don't have full control over that. So I'm not going to talk about the right-hand side. The only chart that's particularly good is the GDP one, creating productivity on the back of all of this brilliant technology that we've been doing. It's shot up, but then so there's all of these other charts, but I'm not here to do my Greta Thunberg impression today. I'm here to talk to you about the technology and how we can harness it. So that's the history lesson complete. Let's talk about AI then, more generically, and where we are today. We have various types of AI, and for those of you that read the text or listen to the podcast these days, that's more often than not, there's lots and lots of literature and views on where AI is, where it's going, how it's going to get there, and what it's going to do to us as humans. Everything that we experience today with AI is classed as narrow AI. We're just this top bullet point. We've not moved to AGI. We've certainly not moved to super intelligence. We're just on that top banner, and that is the things that if I say Siri, Alexa, Watson, ChatGPT. You know about these. You hear about these. You probably are using these, right? This is what we know. And we know that algorithms are very cleverly looking at everything that we do and working out what we should be doing and telling us and giving us those feeds, and we just digest it naturally. That's an AI algorithm that's working out what it is we should be looking at next. Then there's this thing called artificial general intelligence, AGI, widely talked about at the moment. This is a technology that becomes self-aware, it learns, it becomes general. Narrow, weak AI is about a specific function. Okay? General AI means that it can do multiple functions. It operates autonomously like we do as human beings. We can turn our minds to different things in different ways. AGI will be able to do the same. It will have access to the underlying compute and the data and have the skill sets with the machine learning algorithms to be able to manipulate itself to create the views of the world that it autonomously owns. Whether or not it's sentient or not, we're going to park that. We'll leave that for another debate, maybe at another lecture. I've given some examples here. I've just put a few up there. Anybody in the room heard of Jarvis? Good, they're the Marvel fans, the Marvel universe. HAL, yeah, 2001 Space Odyssey. David, remember it was we've got a hand at the back, yeah. So David was the cybernetic organism that was a young boy. It was Haley Joel Osment, and he was in the film AI, and he was AGI. He's an example of AGI. And my favourite one in here, because I threw it in because I didn't think anybody would really know this one, is Zen. Does anybody know Zen or remember Zen? Okay, just me. A sci-fi program called Blake 7. That was Zen, wasn't it? Yeah, Blake. Yeah, he was in charge of the spaceship that could travel faster than light. So it was very clever. But that's what AI is of that type, right? It's clever. It's got vast amounts of data, more than we could ever comprehend as biological creatures. And that advantage is going to take it beyond where we are. It's going to help us go beyond where we are now as well, as we become augmented with it, but ultimately those are examples of types of AGI. Then we get into the real sci-fi stuff, and we call it, I call it sci-fi, but I'm actually, this is going to happen. It might not happen like Skynet and Ex Machina, but AGI will bear a child called artificial superintelligence, where everything is accessible to it in real time with its own machine-learned algorithms. It's making its own mind up. At this point, it probably is sentient, probably is determining what's best for the planet, for the world, for its existence. Are human beings good for its existence? Maybe, maybe not. It'll make it with its own mind. Then, the real theorists in the room that have done the reading on AI will know that you can then go into things like transcendental AI, cosmic AI, or even godlike AI. If you get to godlike AI, the whole everything, the whole universe, the particles, the quantum particles, everything is controlled in a quantum AI sense world. Not a world to look forward to, I should imagine. Or it might be completely perfect and the best life ever. Who are we to know? So, how does AI evolve? How do we get from narrow, weak, to AGI, to superintelligence? Well, it learns. It learns from mechanisms like this. Don't worry, this is the most text you're going to see on any of my slides. I'm not going to go through each and every one of these. I'm hoping that there's people in the room that have heard enough about AI that will recognise some of these phrases like generative models, and supervised and unsupervised learning. These are the types of ways, just some of the types of ways, there are other types, but these are the predominant ones, that a computing technology evolves and learns, processes things. Ultimately, let's take some water. Ultimately, we're just processing its maths. It's vector algebra, it's linear algebra, it's Bayesian theory, it's probability theories. We're processing using those kind of mathematical principles, data that's being put into it in whatever mode. Remember, we're talking about modalities. It can be video, it can be text, it can be numbers, it can be whatever that input data is, manipulated via algorithms and mathematical principles to create an output. That's what we're talking about here, whether or not it's a supervised learning machine like an IBM Watson, some of you will have heard of that, or an unsupervised machine, which an example of that would be your fraud detection tools. Looking for anomalies, things that doesn't normally happen. Looking at all of this data, these things don't normally happen, flag them up, create an alarm for somebody to do something about. It might even be automated. Then we get into semi-supervised learning. Good examples of those would be Google Photos, where you're looking at lots of imagery and being able to, looking at all of the imagery, determine who that person is, identifying that person, or still looking at imagery and looking at the medical sector, looking at images of scans to determine whether or not something is potentially cancerous or not. AI and the mechanisms that were already in use in practices in medical centres across the globe are already doing a better job at identifying that than humans can. It still gets validated by a human doctor, but eventually, why would that need to happen if it's already so much more efficient than a human being? Semi-supervised learning, that's more protein sequencing, that kind of thing. We can't do protein sequencing without bringing together certain types of computing, like quantum computing, along with AI learning, and you can sequence proteins to actually see how they fold. And that is something that classical computing can't do, and humans can't do. Reinforcement learning. Best example of reinforcement learning for me is DeepMind's, that's Google DeepMind's AlphaGo platform. Anybody played Go? It's the oldest board game in the world. Has anybody played Go? Yeah. No, just us. Yeah, I'm trying to learn how to play Go at the moment, and I'm very close to giving up. But it's the oldest board game in the world, and it was a game that prior to where we are today, the experts at the time said that the computer would never be able to play Go. It's just there's too many variables in it. There's no science to it. There's skill, and the computer will never have that skill. Computers have had that skill, and computers have beaten the world champions at Go. Now, what is most freaky and scary for me in that discussion is it took the computer 4 days of learning. The computer was blank. It was given the Go algorithm and said, learn how to play this game. 4 days later, it beat the world champion. And it did things that the world champion and the experts of Go across the world who were watching this big challenge were saying, well, it's thrown a double six here, it's not working properly, why would it do that? 20 minutes later, game over, AlphaGo wins. So, we don't know the answers. We can't train these things. It's going to train itself more and more and more and become much more better than we can ever possibly imagine, frankly. Generative models, you'll be familiar with those. Loads of stuff at the moment in the market about OpenAI's ChatGPTs, 3 and 4, 3.5. They're large language models. DALL-E is a graphical version of that, the creation of imagery from just typing in some words, and you get basically what you type in an image. And then obviously there's a new platform that OpenAI have just launched, which is called Sora, or Sora as they pronounce it, which is another one of, it's a multimodal tool, so you can put whatever in, it'll give you it back out in whatever kind of mode you want to see it, video, text, graphics of whatever type. So, and then you get what we call, really get into the techie stuff here, convolutional neural networks or recurrent neural networks. These are algorithms that work in software that work more akin to the way our brains work. That's why they're called neural network. They have billions of connections connected to billions of storage points. Okay, and it learns and adapts and translates. It can do text to speech. Is a good example of this kind of thing. Real-time language translation, neural networking at its best. Speaking into one device and the person you're talking to who can't speak your language is getting full translation, real time. So, as I say, I'm not going to labour any of these. I'm just giving you some examples along the way of what that chart really means. And these are not all of the types. These are just the larger, more regular ones. And if there was some students in the room, I would ask them which one do they prefer. But there are no students in the room. Everybody likes to have a student in the room. It's need somebody to pick on. Right. So we've talked about a little bit of history context. We've talked about AI, how it evolves and grows. Now we're going to talk about how that is being brought to life in a telco environment, because we are a telco group of people. So I need to help you with this. So what kind of things are telecoms operators, altnets, ISPs, whatever you want to call them, whatever flavour you are, using AI technology? Chatbots is an easy example that everybody can relate to. These could be textual, or they could be avatars that are talking in a more video interactive sense. And some of those avatars are getting very, very good. You can barely tell these days if they're actually real or simulated. But you can have those, and there's 20 to 25% of your operating costs typically in an operator environment associated with the front end roles that would engage with your customer base that you can start to address and certainly reduce, and maybe one day ultimately completely replace. Hyper-personalisation. If there's one thing we love about AI, the AI realm, it's that it comes with its whole new set of cleverly, brilliantly phrased marketing. Hyper-personalisation is simply just having the most up-to-date recent content associated with the person you're having the engagement with. So if you are that customer services operator talking to a customer who's just rung in again about a certain problem or a different problem to the one they had last week, but you can see that they had that different problem last week. It might even be related to the problem they're ringing about, and you can say, I'm sorry about your problem last week. I can see you on the phone for an hour and 45 minutes. Really not our best performance, but let's see if I can do better right now for you. All of a sudden, the angst and the pain and the anger that person's ringing up again for the second time in a row has just dissipated. They really get me. They know. Hyper-personalisation, that's what it is. Marketeers love this. Smart coaching. basically it's just clever training, you know, which is just a clever way of saying smart coaching using different words. Smart coaching is just bringing your workforce up to the skills and abilities that they need, and then expanding them. We sectionalise and categorise people to be this type of engineer, that type of engineer. But if this type of engineer has got more about them, or don't know they've got more about them, but the learning that you've given them shows that they have the potential and they had a particular nuance for this particular field, let's steer their development and train them in other fields that they're going to enlighten them and they're going to make them want to do that work. There's nothing better than having people, employees, working in an environment that they actually want to do that. I'm excited, let me do that. So you can identify those things, and then you can then monitor them thereafter. You can write it into their performance reviews, and be really manipulative and let the AI tell them where they're good, bad, and indifferent, and why they're only going to get a 2% pay rise rather than a 4% pay rise. Optimising field operations. So the 20-25% of front-end staff engaging with customers, but the field operations anywhere between 40 and 50%. That is a big cost of your OPEX overall, and frankly, there are tools out there. Some of the, I think one of the speakers this morning mentioned ServiceNow. Tools like that are having embedded AI modules added to them to bring together the optimization of a lot of the workforce by just using algorithms to make sure that the right person with the right tools, with the right aptitude and the right availability goes to the right job. All right, just little things like that. And the person that does that is obviously the best person and the closest person. There's a lot of potential there. Route optimization in a more traditional networking sense, using algorithms to determine that actually, if we've got all of this traffic going to these places, why haven't we got direct peering relationships with those organizations? We should get them. So we'll save money and it'll improve the user experience because they'll have low latency. So these are some examples, and I think any operator that says that they're doing all of those and all of these, because here's another set, is probably not being quite truthful. So what we've got here is self-healing. So you can use the same technology to look at all of the data, that your telco network data, your analytics data, bring those two realms together and work out the best way to recover the network operation when it's failing because there is a DDoS attack going on somewhere in the network. You're being attacked somewhere. Right? It's not taking everything down, but we know that this community of users will be having a service impact. We're going to route those users to a different route, a different peering relationship. Might cost a little bit more on that time, but you're not going to get the bad press that comes with an application service being down. Maybe like last week with Meta's service issues, but I'm not suggesting it wasn't because they didn't have Canopus. So you can do self-healing, but then the cleverer stuff is really the predictive maintenance. So before there's a problem, you've looked at all of that data that you're collecting from all of your systems, you've analysed it using your AI algorithms, and you know that these things are going to start failing soon, so let's fix them before they go wrong. Personalised recommendations. There's a little bit of a green box about all these two bottom ones, because this is where I'm going to bring in Canopus. This is what the Canopus software will do. It will look at the personalisation of the data. Again, this is about looking at a subscriber, working out what type of subscriber are they? What do they really like doing? How can we step into their psyche of knowing what they do without freaking them out and thinking, Jesus, how did you know that about me? GDPR does rule at the end of the day. But you get those personalised recommendations to give them a flavour of the service that you standardly offer that is uniquely tailored to their needs. Okay? So if there's a gamer, for example, you give him a gaming service. The gaming service is super low latency. You give him a quality of experience, the TCP headers and the routing of the traffic across the network is optimised for low latency, low jitter, shoot 'em up performance. Unless of course they're a strategy gamer, because that's not important. So you can give them a strategy gamer profile. And then real-time network analytics. This is in the sense of what's really going on the network. There are tools in network operating centres all across the world that can tell you We've got this amount of bandwidth going across to these routes, using this network, using these BGP protocols, blah. But actually, the network is being used for applications. It's people like us, or computing devices in some instances, working across the network, shifting application information. So it's applications we want to know about, not the volume, the number, the performance of the bits and bytes that are going across the network. We want to know about the actual flow pulses. I'll come back to that phrase. So, I don't know where this will come from. Before I put Canopus into context, we're on an AI journey, an AI adoption pathway. In my view, and if anybody wants to challenge me here, you can. My view is we're somewhere between awareness, around tactical, still learning and about awareness. Tactically, we might have done one or two things that we might have introduced on the back of a vendor, say, I've got an AI module, I'll introduce it into your existing deployment. And then operationally you start to introduce that. But you haven't gone fully operational AI. You haven't gone strategically evolved into an AI subsystem way of working with digital data, making decisions almost autonomously. And you certainly haven't gone to a mature model where everything is just working and all you need to do is just give the AI machine a thumbs up at the end of it. When 90% of your workforce is gone and you're doing everything intelligently using algorithms. That's a while away yet. But I fundamentally believe it's coming. So does anybody think that they're more mature than potentially a bit of operational? Anybody in the room think they're really advanced? Yeah, even the Microsofts of the world. Oh, there you go. That's good. I've got a bit of a way in my hand, so you might have gone a little bit strategic, right? You didn't put your hand up earlier when you said you were when I was talking about AI experts, so you can't ask any questions at all. Right, I found a graphic, and when I found this graphic, I thought, I've got to use this graphic. An AI, artificial intelligence, surely it produced that graphic. But if you did get to that mature model, then you will have done some or nearly all of these things that are on this list. I'm not going to talk to these things, but you'll be all digital and integrate. Everything will be integrated into everything else, including your workforce, your people, and the way in which they work, the processes, the systems, the people. You'll have an agile mentality. DevOps will be prevalent. You'll have scientists. You won't have engineers. You'll have scientists working for you that are profound in writing variables that go into AI algorithms and scripts that work into your tools to give you a true orchestrated view of your entire business from a top-level graphical tool that just a handful of scientists and a handful of field engineers, because you will always still need field engineers. They're not going anywhere soon until robotics really catches up, but right now, that's a good couple of decades away at the earliest. You will have embraced a customer-centric environment, which has got an ecosystem to support that. What does that mean? You have a catalogue, and your catalogue can be quite dynamically and quickly evolved to be what it needs to be. You've got a particular data set, you're a particular operator, this is what we do, this is the services we sell. Actually, the data that we've got and the algorithms to control that and manipulate that data mean that we could also, because we've got 2.5 million customers, we could offer data that suggests that these 2.5 million customers are good for credit or not. They're regular payers. We've got this data, we've got this insight. You know, so we've come to flex into different genres and have different product lines. Anything as a service, that's an example of anything as a service. So if you've got good data, you can take that data and you can make it something meaningful and expand into new sectors. Cloud native, another great phrase that's talked about. Everybody know about cloud native? Loads of nodding heads, and I'm not sure all those are nodding heads because they say they know about cloud native. But cloud native, microservices and the way in which they interact and work, that is the platform, the compute platform that's going to underpin AI. It's going to be, so your AI is an algorithm, it's clever, it's learning, it's sitting in the cloud, it's making all of the decisions, and 99 times out of 100 they're making the right decisions. However, they don't always make the right decisions, thank God, because if they did, we'd all be superfluous, and wouldn't that be tough? We'd have to spend all of our working weeks on the beach instead. But the reality is there are risks with AI, clearly. It's not the be-all and end-all. It will be, I absolutely believe that, But during the next few years, there's going to be some learning lessons. We know about hallucinations. We know if you're putting in erroneous data into the system to be analysed by, no matter how good the algorithm machine learning is, if the data going in is wrong, it's going to give you the wrong answer. So we've got to have the right data. We've got to be aware of the fact that it's evolving and learning itself, and that it will make mistakes from time to time. And we need to be able to review that before we press the go button.
How do you know you've got the right data?
How do you know you've got the right data?
Well, at the moment, we've got data on the internet, which is put there by people.
Mm.
We're getting more and more data that's generated by AI based on that data. Some of it's right and some of it's wrong. The sheer volume of data that's going in is going up. So when AI looks for an answer to your question, it's looking at answers that's already generated itself. How does it know that that's the correct answer or the wrong answer?
Yeah.
Are we now getting to a stage where we're getting more and more AI generated, and we have more and more skepticism than what we're getting now?
Absolutely, and deliberately so, and manipulated by politicians and criminals and anybody who's got their own agenda can use an AI to create enough collateral to make you think, well, look at all of those papers that prove that AI is always going to be nice to us and never going to do anything bad. We've got to believe that. Anybody with the right tools can do that. So you're absolutely right. That's what humans have got to bring to the table, is that authenticity to the data. And that is not an easy thing to achieve, because you really have to be able to validate and use the 4 C's, the four C's of learning, and critical thinking, communication, collaboration, whatever the fourth one is, it's escaping me. But you've got to take that view and test the AI to make sure it's right. And over time, you become so comfortable that you do just believe in it. But you're absolutely right, you've got to get the data right. But I'm talking about your data in your enterprise environment. So it's your data to make sure it's clean, your customer data, your billing data, all of that. Then you merge that together with the data you're getting off the artificial intelligence tools. And so it is within your own domain, so you should be able to make sure your own data is clean. Okay, so I'm going to talk to you now about Canopus. So Canopus, of those examples of telco use of AI, those 2 bottom ones that the last highlighted a little bit green, didn't come across very well on here, personalization and the user experience on the network analytics. We're going to prove that's what Canopus can do. Canopus is an organisation that's based in Australia. It's a startup, it's been around for 5 years or so now. It's got a whole raft of data scientists or ML scientists working for it. So some bloke called Gilbert is one of the guys accountable for the EMEA operation, as long as a bloke called Lambert. There he is. If you want to know anything more about Canopus, I suggest you ask me, because he's pretty useless. They've got deployments. Oh, there you go. I've invited now, haven't I? When he gets the Q&A now, you're going to kill me. Deployment-wise, there's deployments in Australia, New Zealand, India, Hong Kong, the United States, and Indonesia. We haven't quite yet evolved into the European market. So what does Canopus do? Canopus, the solution is called FlowPulse, and it's an AI-driven terabit-scale, encryption-proof, real-time application analytics tool. It's beautiful, isn't it? Absolutely rolls off the chain. I mean, we love that. I mean, what that basically means. There's some key points in here. So it's terabit scale, so it's real time. I mean, that also makes it real. It runs on the latest levels of compute. P4 programmable switches run the AI algorithm. So the AI algorithm sitting on the latest tech, sitting in a cloud somewhere. And because of the way the AI works, and it's looking at pulses of information, it determines what that pulse of information is based on a profile. And it doesn't need to look at the bits and bytes that make up that real-time traffic. It's looking at the flow pulse, and I'll show you what a flow pulse looks like in a moment. Which means it's encryption proof. So we know if it's WhatsApp, Netflix, Amazon, Disney. We know that. We don't know what Disney film it is you're watching. I see there's a big Frozen community here, but after you've watched Frozen, we don't know what else you're watching. So for me, it's about knowing what all of your traffic is real time in a nicely presented front end, which I'll show you as well. And with that information, you can optimize your network, optimize your user's experience, and unlock the value on the back of that. So what does it look like? So we build, there's a network agnostic. This can plug onto any type of network. It can be fiber, it can be radio, it can be 5G, it can be coaxial. And we come along, we deploy the Canopus solution, run it on, it's the AI algorithm running on hardware, which is terabit scale, latest tech, uses a couple of sources of supply for that. We have clever APIs that can push out to whatever other systems an operator might already be running, and we also have a chat GPT front end, which is pretty cool. If I've got time, I'll come back to that. And then there's a group of professional services personnel over in Australia. And what happens is, it gives you the view of really what is happening on your network. Not the bits, the bytes, the net flows, the syslogs. This is the Google Mobile, the Instagram, the Ookla speed tests. Which of your customers are doing speed tests? Wouldn't that be useful to know? You know, if they're doing that, then chances are they're not happy with something. So let's intercept them and do something proactively with them. What games are they playing? How, when are they playing them? How are they playing them? How can we make this information personalised into a way that means that we can productise something that makes us all more money and our customers happy? Architecturally, it optically intercepts at the aggregation point. So your border network gateways, just in front of those, wherever you best see the aggregation point to be, you insert optical taps that feed just an optical signal, so it's just a mirrored optical signal, and 10% of the signal goes off to a probe, it's looking at that. Everything else is working just as it was before, even it's putting an optical tap. This is what makes it real-time and non-intrusive. The probes then do their thing. These are your P4 switches that are programmable with carrying the AL algorithm. It goes via a Kafka data manipulation function with it, which you actually see on those probes. The diagram's a little bit flawed in that respect. And it presents itself on the Flow Pulse analytics tool, which has lots of open source data manipulation and presentation tools within it, so that you can integrate it into your existing BSS OSS. I wasn't going to talk about any of these. I'm sure hopefully some of these on the right hand side will be, I can talk to them if you want me to, but I'm not going to do that here. So I've talked about flow pulses, I've talked about how we look at this to get this, how do we get all of that information? How does it really work? What we're looking at? So hopefully this will work. There you go. Can you do that? That's what a YouTube flow pulse looks like. That's what a WhatsApp flow pulse looks like. Now what we've got here is black and green, and WhatsApp is two-way interactive, so there's a push and a pull of data. Instagram is predominantly just pulling data down, we're watching video reels. This is a shoot 'em up, so it's needing the control of where you're shooting, what you're shooting, how you're shooting, what gun you're using, and then it's actually actioning it, and this is a zoom profile. So that is the kind of thing that this tool is looking at optically in a real time, sub-millisecond processing. And it gives us that view, and we can then, with all of that data, take forward a product proposition which Canopus group like this. So 3 product propositions. The first one is Network Pulse, which is targeted at your CTOs and your Chief Operating Officers to improve how the network works. And it delivers, you can see, you can read this table as well, it improves return on investment, the money that you've spent, etc. Whereas the user pulse function product set is more about targeting your Chief Marketing Officer or your Chief Product Officer to evolve using that personalised view that you've just gained of all of your customers, using all of their devices to do whatever they're doing, to give you a view of that information and then therefore personalise the solution that you're offering to them. It's all about KYC. Does everyone know what KYC is?
Know your customer.
Yes! Thank you. I had to look it up, I must admit. But I'm not a marketeer. So know your customer data. Once you've got that, you can do that. And again, you get these kind of benefits. And this one on the right hand side, I'm not pushing. This is about taking you beyond the realm of what we can legitimately do in Europe at the moment because of GDPR regulations. Okay? This is about taking that data that you've got on your customer base and getting more value out of it by selling it off to other brokers that can use it and be more targeted with their marketing and their advertisement. Certainly seen a lot of that in Asia, where we've been selling, because they're not so bothered about data protection over there. But we are actually seeing quite a lot of that in Asia, but not over here for obvious regulatory reasons. So just one extra slide before I'm ready to jump into a quick demo. We've got our friends McKinsey, so you can give personas to all of your customers, and they can be variable. They can be one at the top left or the top right at different times of the day. You know that. You know when the gamer stops playing games and at 11:30 at night he decides to become a gambler. You know this about your consumers because you can see what they're going, where the TCP address headers are telling you where they're going, and where we don't know where they're going because it's encrypted, we can work out from the AI algorithm. So we know everything about what you're doing. We don't know what you're doing, we don't know what you're betting on, we can't see the actual content of the streams, don't know what film you're watching, but we do know what you're doing, where you're going, what your community of interest is. Remember, this is network agnostic and it's all real time. And McKinsey would tell us you'll get 40% more revenue if you can do this level of personalization. Right, I've got a summary slide here. This is just talking about the benefits, the value user cases that you get from deploying that technology against that product line, giving you these benefits. That's a little bit product placement, and I don't really want to do that here. So, have I still got time to do a quick demo? Yeah. Okay, I'm going into dangerous territory here. I'm going to do a real-time live demo.
I think it's important you say that this is the university in Australia.
It is, and I will.
And this product comes out of academia, so it's not a product that comes out of the Valley, it comes out of an Australian university with a bunch of PhD.
So, I mentioned earlier that it's an Australian company, Canopus. They are based on the University of New South Wales campus, and they have an installation there. And this is what it looks like right now, except 12 hours in advance. There are 16,902 active users, drawing on average 117 kilobits, 900 megs upstream, 1.9 gigs downstream, and there are 5,260 active flow pulses. The pie chart views that you've got here is telling you what the largest student community, because there is faculty in here as well, different departments. It's just telling you what they've been doing over the last hour. So you can see. So this one on the left-hand side is just a generalised view of what's been happening. Video consumption to the right, non-video consumption, and then if you look at, we've got gamers, but this is all tailorable, but we've got gamers there, so you can see in the last hour there's been 13 instances of Valorant being played. I'm not particularly a gamer, so I don't know all of the gaming language. So, and then at the bottom you just see all of the types categorised. Remember, this is real time, this is being refreshed all the time, it's just getting refreshed every 30 seconds on that bottom chart. And you can tell that right now there's 21 current game flows. These are current monitored, so the number of flow pulse counts has just changed. So I've mentioned to you flow pulses. Let me show you what flow pulse looks like. I've showed you it on the presentation earlier. Let's look. So these are all the flow pulses. Let me just scroll down. There are 218 pages, each one with 18 lines on it. These are all of the flow pulses. So for every single session that anybody's doing in New South Wales on that campus right now, we're looking at those sessions. And it tells you. So the top one at the moment is an Amazon Web Services download. You can see the speed rates it's going, you can see the CCP addresses it's going at, that's the user unique value. I'm not sharing anything here that's GDPR non-compliant. And I'm just going to show you what that actual flow pulse looks like. So we've got a downstream and upstream bit rate. The downstream here is the peak, the purple, and the upstream, so this might just be a very short burst, yeah. So this is an Amazon Web Services download. It will just be making a request and then sending a pulse of data, and then requesting a pulse of data. And that's what these spikes are. Those spikes are the pulse of data that you're then making up the video or the content that it's recomposing on your PC. This is real time. This is, somebody's doing this right now at 3:15 in the morning. Okay, I know what students are like. I'm desperate for a student in the room. So they're all the flow pulses. Then we can show you the profile based on users. Remember, users can have multiple pulses. This is just that top one. I can't remember, what did I pick there? I can't remember what it was now. If we go back. So so I'm picking this particular user has got aggregated volume of services. So there might be, when we're at home, we have our mobiles, we have our TVs, we have our laptops, we have our PCs, we have whatever our kids have got, if we've got kids, or the visitors they're bringing into the home. So there's multiple devices doing multiple things, and we can tell which device is doing what at any one time. And this is the profile of this particular user. But it looks like whatever he's doing right now is just, he stopped doing it, and it's just ticking over. Group Pulse is just aggregating that into the departments that exist across the campus of the university, so that they can do billing of the volume of traffic that they use and apportion the costs across the departments accordingly. So these are faculty departments. And then I'll just wrap up by picking on gaming. Right now, let's have a look at what's going on. And this is where we start to show the user experience element of this as well, so we can see, are they having a good gaming experience or not? So there are 20, just changed, gameplay sessions ongoing at the moment. And if we look at this first top one, we can see it's having a medium customer experience. So let's have a look at what the problem is here. I always get a bit nervous when I get to this level of granularity. So looking at one particular gaming experience, which is a Roblox. Anybody know what Roblox is? Is that a game?
Yes.
Nobody? Yeah, it's a game. Oh, we've got, see, you know what,
Yeah,
brilliant.
I know it well.
So this user is playing Roblox right now, and a few seconds ago they weren't getting the best network performance. There's that amber section there is saying that there was a quality of experience that wasn't optimal for that particular type of game. You set these thresholds as you decide, right, a Roblox user experience needs to have this kind of quality of experience criteria, and you can define that. And if it exceeds it, it triggers it and it makes it amber, and it gives you the indication here. And if we just scroll down, we're seeing the real-time jitter, the round-trip times, the server round-trip times, and I think down here, yeah, there was a packet loss of more than 5%, so it gone to 7.5% packet loss, which has meant that it's triggered for those few seconds an amber experience on that service. So again, you're looking at the real-time transmission, the real-time characteristics of a real-time user experience in Australia right now. And we can do that for video, for conferencing, for cloud. We can look at that historically. There's an analytics tool, which is another front end to this, that looks at all of the traffic profiles historically, so you can do trending. We can look at this from a provider's perspective to give you what games. So here's all the games that have been played over the last 24 hours, the volumes of them. You can see hopefully some of those. FIFA should be one we all know. But yeah, that's what they've been playing, the volumes they've been playing it. And you can see, if you wanted to, you can go into each individual user experience as well. Last but not least, these clients, you can see what games they've played over the last 24 hours here. Let's have a look at that experience, and that's showing you these are the games that they played when they played them. Right, I didn't start my timer, so I'm not sure if I'm close to the time. Do you want me to do another couple of hours? Yeah. I'm going to come out of that now before you start. There's nothing here that, from a GDPR sense, that you can't see. But that's going to come up. Right, proud of that graphic. Took ages to create that. No AI was used in creating a rotating brain. Any questions?
Now I can see why UK had a problem with the post office. You're not here. You're here to solve our problem.
Well, AI will solve the problems it won't me. But if anybody needs assistance in the AI world, I can come and talk to you. It's been very high level today, but we can step down into levels and help any organisation move into a more AI-centric realm and operation.
You move to the back. Come on.
Gotta get fit, bud. Awesome presentation. Can you hear me?
Yeah, I can.
Okay, cool. One comment, one question. It's weird how similar a lot of those graphics look to just a standard spectrum analyzer graphics that most of the cable guys are pretty used to looking at modem pulses and data flowing through, so that's kind of weird. But
yeah.
Where you're splicing, on your block diagram where you spliced in your 10% tap off, is that bidirectional? Where do you put that in? Is that bidirectional? And are you looking at that both ways?
Yeah, I can address both of those. So let's just go back to the spectrum analysis. The real difference here is that we're looking at everything real time in an application sense. So you stick a spectrum analysis tool somewhere on the network, you're looking at that particular part of the network, it's not all being brought together in one analytical view, and you're looking at the applications. Now I appreciate you can look at spectral analysis real time, but this is application views real time, so it's working out what the actual user experience is actually being carried across that network point. And to your second point, optical taps, yes, they are bidirectional. It's just mirroring a small section. The optical taps are it's not new technology. I'm sure there's people in the room that will be familiar with optical taps. You sit them in series, most of the traffic bypasses through, you just refract a little piece of the light out onto another pair of fibers that go into the probes. So and the probes and all of the Canopus solution is sitting there out of line, doesn't affect the service experience of the customer whatsoever. It's just giving the operator the experience of seeing everything that's really happening on the network. And they do tend to do that at the principal aggregation points as well. That's the best place to capture all the traffic.
Yeah, very good presentation. I enjoyed it. Thank you very much. Given what the EU said, or just passed yesterday or the day before, regarding AI, data manipulation, looking at GDPR, all the rest of all the old things, they're clamping down on a lot of these things. How do you see that impacting when an operator wants to find out more and more about what their network's doing, but the EU says less and less about what you're doing? Is that a contradiction? What can you sort of say about that?
Yeah, it's interesting. I haven't had a chance to get fully. I saw the headlines, but I didn't get across the detail. Governments generally in the Western world are being quite proactive about adoption of AI, and they're not heavily regulating and stamping on it because they don't want to stifle their economy, frankly. Especially the UK, we're a tech leader in this type of evolutionary digital technology. Last year, the UK government published their legislation on AI. It's out of the Department of Science, Innovation and Technology, and it wasn't heavily regulated. It was monitored, it was reviewed, going to have regular reviews, we're going to have certain standards that we want people to adopt. And what the European news is, as I think I understand it, is that they're tightening up on it a little bit. And I think all of the frameworks, frankly, probably do need to tighten up a little bit. We are unleashing the genie. And if we don't do it carefully, I mean, there's so much news about this in the world. God knows how much of it is real, to the point about is this real data? You know, the likes of Elon Musk and some of the leading tech leaders in the world that are standing forward and saying we're going too quick too soon here. We're going to create could be the end of civilization if we give something else super intelligence much more than we are. Why would they need us? Why would a super intelligence being that was self-aware need human beings on the planet? You know, would the planet be healthier? Would there be more animals living? Clearly. Would there be less consumption of bad things? Clearly, yes. Would there be less pollution in the atmosphere? Yes. So, we've got to make sure that the regulators and the governments work together. And that's the big challenge, is getting them to work across the globe, because it's all very well Europe doing this and being consciously right. I think that's probably the right timing. But are China going to do that? Are Russia going to do that? Are America going to do that? Well, is there any Americans in the room? There you go. The other ones I trust the least. But yeah, you've got to. It's a race, and we're all running, and we're all creating things quickly, and we're not necessarily. Have we already gone past the point of no return on that race? I don't think so. I don't think that's real. But some of the scaremongers will tell you that we have.
I was slightly different on that, in that if it, this is just, gossip, but if it sees human beings as being irrelevant, it's going to see itself as being irrelevant.
Yeah, well, you're getting into transcendental AGI and there. It will not. It's interesting because this is all about consciousness, and it's awareness of what it is and how it works, and the environment that it exists within. If it feels that we are damaging that environment, that it needs to exist, and that it's made enough AGI and robots and technology to service all of its needs, it's a Skynet kind of scenario, isn't it? But I think the only thing that's wrong, I'm going to be bold here and make this bold statement, please don't quote me in any SE2 press, the only thing that's wrong with AI is humanity. The things that we're worried about AI doing are because it will have learned how bad humans are. All right? So, we've got to make sure it doesn't learn that.
We can discuss that forever, but...
So, this very interesting product and how it can sort of see, really dig down into what users are doing. How would a user with a VPN, for example, break that? So you're not only looking at the endpoint, which would be masked by a VPN, but also the type of traffic. So
Yeah.
do you still detect that, or?
No, well, we've stopped. We can theoretically break down VPN traffic, but we don't. We shouldn't. VPN traffic's there for a reason.
Yeah.
So we can identify a VPN and the type of VPN that's going between A and B, but analysis beyond that is not what this tool will do. I think AI technology will evolve to be able to do exactly that. In time they can break down anything, and they will. And the criminals of the world will find ways of doing exactly that and de-encrypting keys that were never meant to be de-encrypted. But this technology will evolve at an exponential rate that none of us can comprehend.
Sorry, do you mind if I'm greedy and ask one more question? So you really drilled down into sort of a user experience, which is great. Is it a bit more also broad scale in the aggregate? So if multiple users in a region are having issues, will it try and sort of analyse and predict what that could be? So for example, a cabinet's down and it's impacted the street.
Absolutely, and for me that's one of the, and I'll just touch base on that ChatGPT front end, which is something we've got in the labs. It's not something that we've actually pushed out yet because it's a little bit scary for the CTOs. Imagine a CTO that had an issue last night on a node, a 5G network, and 7 cells went down, and it was down between whatever time period. But his chief exec can click the button and ask the GPT front end, tell me what happened on the network last night. And then ask the next question, how long was that out? How many customers did that affect? What was the user experience? And then he's going to correlate all of that information that he's got from the data from the AI algorithm with what his CTO is telling him. So the days of CTOs say, wasn't us, it was a problem in the peering routes with such and so, or it was user errors X, Y, Y. Those days are going to go because it becomes simple. That's one of the beauties of the technology, is that it makes it really easy to interact with. We all love the large language models, and we all have fun with them, and some of us are using them really productively. So yeah, I think that locality, it can flag up reports and hopefully give you early indications as well. If you've got a customer base that is 90% dormant, but the 10% that's live are all having service issues, you can bet the minute that they start picking up the phones, they're going to have problems as well. So try and get to those problems soon, and you've seen it all real time. And you can make it geographic, you can make it user experience, you can have particular high profile customer clients, public sector organisations, government organisations, etc., that you group it by, it's your telco data married to this analytics data, and you coordinate and group it as you see fit, and you can have all sorts of reports.
You guys are both teeing up my talk, by the way.
Sorry?
You're teeing me up.
Oh, right, great. That's 1 minute, sorry.
Yes, I don't know if you spotted it, but there was a statement a couple of weeks ago, I think, from a senior guy in one of the oil companies, I think it was Shell, and he said that AI would be have a major impact on their future business, but not for any of the reasons you've been giving today. It was because he reckoned that AI uses vast amounts of computing power. It's already overloading data centers, so there'll be a lot more data centers, there'll be a lot more power required, and hence more gas.
Yeah,
Got any thoughts on that?
No, I agree. I think the digitalisation of the world that we're seeing, that we can't deny, it's happening, and it's going to continue to happen at an exponential rate, is going to draw more power. Electrical cars draw more power than, but they do less damage to the environment. The world is going to need that power, and but do you know what we're going to have? We're going to have clever AI is going to tell us how to solve the power problems. It's going to redesign batteries. It's going to take more solar energy. It's going to create scenarios for us. This is the theory, isn't it? This is the.
Well, no. So I actually have a slide specifically on this. There's published data that I will share with you in a few moments. It's been investigated by a large telco in Europe.
Yeah,
Thanks, sir.
he's a believe you because you're American, so you went.
You don't believe me? It's not my data.
I take back the disparaging of all Americans. This one's okay.
It's not my data.
Yeah, you're a nice American.
I'll point you to the source.
Got one more. Any more questions?
Yeah, just
Oh,
one
sorry.
more from me again, sorry. As you actually gave us a product demonstration, commercially, how do you represent the product to the market? Is it per user, per customer, per license? How do you sort of sit this in front of somebody?
Yeah, happy to talk about that offline. I don't really want to do it in the front room, but it's a license-based tool based on the volume of people that you've got on the network. And frankly, I'm going to say this, but it is very cost-effective compared to deep packet inspection kind of tools that are more prevalent at the moment across the world. This will displace DPI in terms of network analytical views, but we can talk about that more.
Yeah.
If anybody wants to talk about the product more, we can take it offline. It's not for this auditorium.
The simple answer to your question is what we think about depending on the situation. But we
Are we good?
Thank you very much.